Hi everyone, I'm Raghu and I'll be presenting my project. So my project's called EurekaPilot. It's a simple agentic AI application to help students with their research ideation. So before I get into the details of the architecture, I wanted to briefly give my motivation behind this topic. So the biggest challenge that students have to face is to come up with their own research proposal, especially at the time of their thesis. So usually how this works is that the professor hands over a research topic or an idea to the student, and it's the responsibility of the student to determine if the idea is already existing or not by manually checking different research papers, and if the idea is already there, he or she has to come up with their own improvement strategies, so that could then serve as a research proposal for the thesis topic. So however, this is a manual process. It's not easy to come up with ideas to read several research papers because it can be overwhelming and it is also time consuming. So we have several AI applications in the market, but most of them are mainly used to summarize PDFs or to generate software, or they can also be used as chat application, but they lack end-to-end research guidance. It does not have an intelligence to read through several research papers and suggest if the idea is existing or not, and to also generate its own unique research proposal ideas. So to overcome these limitations, what I've built is an agentic AI application that I have called as EurekaPilot. So this acts as a research companion to the student. So in simple terms, given an idea, it determines whether this idea is already existing or not by going through several research papers, and it gives a novelty score. And if this idea is already existing, it also suggests different improvement strategies, and it gives basically a research proposal that could be used by the students for their thesis. So in this slide you can see a simple user interface of the application. So we have two terminals. So on the left hand side we have the input terminal, and on the right hand side we have the output terminal. So on the input side, the user submits the research idea, and the intelligent AI application here will determine if this idea is already existing in the it's already existing or not by going through the research papers, and it gives a novelty score. And since this, for example, this detect COVID using deep learning idea is not something which is unique, it also gives certain techniques or improvement strategies that could be used for a research proposal. So in this slide we have the architecture of the application. So the process begins when the user submits this research idea through the user interface to the application. So the user interface is built using Gradio in this case. So once the research idea is fed into the application, the agent controller creates a structured to-do list. So it basically defines how the system must behave. So I have avoided the use of any external tools to build the agent controller. It's a simple Python loop based algorithm. So what it does is to define the task and define the tasks, I mean. So and these tasks are to search, analyze and generate. So each of these tasks are executed using different tools. So the first process that gets triggered by the agent controller is the search operation. So what happens is that given a research idea, so the application determines whether this idea is already existing or not. So for that we need to compare with the existing research papers. So what the research tool does is it checks if there are any research papers that are available in the RAG. So So for RAG, I have used Chroma DB. So if there are no papers available, if there are no matching research papers available in the RAG, so it then falls back to the semantic AI. So semantic API, sorry. So it picks the top five research papers that closely matches the research idea. So it basically filters out only the topic as well as the abstract, and it then stores in the RAG so that it could be used in the for other queries. So what we now have is we have the idea, we have the papers that closely match with the idea. So this is part of the research task. So what happens now is the agent controller now triggers the analyze and generate task. So here the LLM comes into picture. The LLM here acts as a reasoning tool. It uses the research idea and the context or the content that has been fetched from the semantic API and or the RAG, and it determines whether the idea that the user is proposing is existing or not. It generates a novelty report. So if the idea is already existing, it also generates improvement strategies. So this strategy then could then be used as a research proposal. So this is the basic architecture of this application. So in simple terms, so given an idea, this agentic AI application generates a research proposal by making use of several research papers, by determining if this idea is already there in one of the in one of the research papers or not, and if it's not there, it generates its own improvement strategies as to what else could be improved from whatever is already existing. So some of the improvements that could be done with respect to this architecture is that the output is not really technically deep, so maybe the technical depth of the output that is generated by the application can be improved, such as like mathematical equations maybe, and so on. So also right now this application is a single agent, so I'm thinking to make it multi-agent application. So for example, such as a critic versus an innovator. So we could also make use of different retrieval techniques. So one of it is GraphRag. So right now the retrieval strategy used is vector-based retrieval, so it is not the most efficient. So in terms of basically the analysis. So the other improvement is to also add source attribution. So that's it, and thank you.